All right, let's jump right in. There's this really common but pretty dangerous idea in system design that if your application is fast, it's automatically strong, that it's ready for some massive growth. But as we're about to see, being fast for just one person and staying fast for a million, well, those are two completely different ballgames.
Oh man, we've all heard this, right? Or maybe we've even said it ourselves. A developer runs a test, it's lightning fast, and they think, yes, I've nailed it. But what happens when you go from that quiet, perfect world of just one user to the absolute chaos of thousands or even millions, all hitting your system at the exact same time? That's when you find out what your code is really made of.
So let's boil it down to the absolute core difference. Performance is all about speed right now for one user. It's that quick response time. Scalability, though, that's the magic trick. It's about maintaining that awesome performance even as your user base explodes. It's the design that keeps you from collapsing under your own success.
To really nail this down, we need to pull these two ideas apart. They are totally distinct, but at the same time, they really have to work together in any great system.
Okay, so performance, the best way to measure it is something called latency, basically how long it takes for one single request to get done. The sports car analogy is perfect here. A high-performance system can do one thing incredibly fast, just like a Ferrari going from 0 to 60. It's all about that individual speed. But scalability? That's a different game. We measure that with throughput, the total amount of work you can get done over time. So forget the one sports car. Now, picture an entire fleet of delivery trucks. Yeah, any single truck is way slower than the Ferrari, but together, they can move a mountain of stuff. That's a scalable system.
And this brings us to a really painful truth for a lot of teams. If your system wasn't designed to scale from the start, just throwing more servers at it is not going to work. Actually, it can make everything much, much worse. Let's dig into why that fast code we talked about just falls apart under pressure.
So why does perfectly good, fast code just break? It almost always comes down to bottlenecks. Imagine your code needs to update one single thing, like a counter in a database. For one user, it's instant. But what happens when 1,000 users all try to do that at the same time? Well, they form a huge virtual line, all waiting for their turn. And just like that, your system grinds to a halt. And this isn't just a theory. There's actually a mathematical law for this called Amdahl's law. It basically says your system's overall speed is always limited by the parts that can't be done at the same time. So even if 90% of your work can be split across 100 servers, that little 10% that has to happen one by one, that's your speed limit. You can't get more than 10 times faster no matter how much hardware you buy. You just can't outrun your bottleneck. This leads to something we can call a scaling tax. It's this myth that if you double your servers, you'll double your performance. Nope. You're far more likely to get maybe a 1.8 times improvement. And why is that? Because now your servers have to spend a bunch of their energy just talking to each other, coordinating, and keeping data in sync. That extra work, that's the tax you pay for getting bigger. All right, enough theory. How does this actually look in the real world? Well, there is no better story than the early days of Instagram. They faced these exact problems with a tiny team and, well, explosive growth. Just let that sink in for a second. 3 engineers, 14 million users, all hitting a pretty standard database setup. How on earth did they handle that kind of load? I'll tell you, they didn't just focus on making their code fast, they made their whole architecture smart. Their core strategy was just beautiful in how simple it was. They realized, hey, not all work is the same. The heaviest, hardest part of their job was dealing with the photos themselves. So they just moved that work. Instead of making their main food truck handle everything, they put a giant, infinitely stocked cooler on the sidewalk for the photos. So here's the recipe. First, every single photo uploaded went straight to Amazon S3, which is just a massive storage service in the cloud. It completely bypassed their main servers. Second, when you went to look at a photo, it was served from a global content delivery network, or CDN, which basically puts a copy of that photo really close to you. All of this meant that their main database, it only had to worry about the tiny, lightweight stuff, like user IDs, comments, and likes. And this right here is the fundamental secret. Instagram scaled not by making their servers work harder, but by making them do way less work for every single request. When you dramatically reduce how heavy each task is, you can suddenly handle millions more of them with the exact same hardware. This all brings us to the modern way of thinking about this. A scalable design is amazing, but in the cloud world we live in now, we can make it totally dynamic. This is the big jump from just scalability to true elasticity.
So what is elasticity? Well, if scalability is the design that lets you handle more traffic, elasticity is the automatic engine that actually does it for you. It's constantly watching your traffic, and it adds or removes servers in real time to perfectly match the demand. That means you're never paying for servers you don't need, and you don't fall over when you get a sudden rush of users. And this is how it really works. You use cloud tools like auto-scaling groups, and you just set up some rules. You might say, hey, if my servers get more than 70% busy, automatically add 2 more. And then, if things cool down and they drop below 30%, get rid of them. The result is a system that literally breathes. It expands and contracts right along with your users. So let's bring it all home with this one final thought. Performance? That's your speed today. It's a snapshot in time. But scalability? That's your game plan for staying fast tomorrow and the day after that, no matter how big you get. One's a feature, the other is the foundation your entire house is built on. And that leaves us with the one critical question you should be asking about any system you're building or working on. Is it just built to be fast right now, or is it truly built to grow? Thanks for joining me.